Hi friends, today we will create system design of ChatGPT. So let's begin with step 1 and understand the functional requirements. So functional requirements. So what ChatGPT does, user can ask questions and the questions are like under a conversation. So create and delete conversations, and we will keep out of scope react to answer images, videos, so the conversation will be text only. Okay, so let's talk about the non-functional requirement, that is our step 2. So NFRs, it has to be highly available, scalable. I think it is most popular application these days, so this definitely need to be highly scalable. And latency, like low latency is good. If application respond and takes like few seconds, that's fine, I think. And consistency, so if we talk about consistency, eventual consistency will be needed, but if additional information comes in reply, that is also fine. So I think we talked about NFRs. This, from this video point of view, this seems like pretty good. So let's do capacity math. So let's assume we have 1 billion user base and daily active user, let's say 100 million daily active users. So 100 million users having 2 conversation per day, and let's say average conversation size is 100 KB. So 100 KB seems like pretty reasonable. And so data per day we gonna store is 100 million, 100 into 10 raised to power 6 into 2 conversation of 100 KB. So this will come out to be 2 into 10 raised to power 9 KB, which means 10 raised to power 3 KB 1 MB, 6 1 GB, and 9 1 TB. So this will be 20 terabyte data per day. So let's say in functional requirement we want to store 10 years of data. So this is going to be a huge database. We need definitely something highly scalable and highly available. TB data per second, let's see what is ingress. So 20 TB divided by 24 into 60 into 60. So 60 into 60, 3600 to 24. Let's call it, to just to simplify the calculation, 20 TB divided by 10 raised to power 5, which will turn out to be 2 into 10 raised to power 5 kV, which is 200 MB per second. This will be our ingress data. So maybe we can use DynamoDB here, which is key value. Key will be conversation ID and value will be the conversation details. So I think DynamoDB will be highly scalable, highly available, and our average conversation size is 100 KB, and DynamoDB support up to 400 KB. So DynamoDB seems to be good for us for now. So APIs here will be post and to create conversation where it will have ID, title, and timestamp, and then we will have post where 1.0 question where user will send ID, user ID, conversation ID, and question content. User should be able to create conversation, should be able to ask question, and in response of question there will be the answer, and in response of create conversation there will be a OK response. So now it is right time to get into the design. User reach to conversation service to create a conversation, and here will be a metadata also. This will be a SQL DB, I'll say ID, name, and account details, account information, age, and maybe email. Then we will have conversation ID, user ID. System gonna be highly scalable system, so all these services has to be stateless. So before going further, let me put the key services here, which will be our load balancer and the gateway. So, and gateway will have definitely a session service up here I'm placing, so that our other services will not be worried about session. So user will talk to the gateway, and gateway will redirect the service to conversation service, and once the conversation is created, OK response sent back to user. Now the story begin. So user will ask a question now, and the question will be redirected to ChatGPT service. This is ChatGPT service, and what it will do, ChatGPT service will record the conversation here, which is our DynamoDB we said. You know what, it could be S3 bucket also. Now I'm thinking, because this is just a conversation which is kind of a document and file getting stored somewhere. So that will be even cheaper option and scalable also. But let's DynamoDB, we can use that also. That should not be, there is no problem in that too. So let's stick with that. So how ChatGPT service will generate answer of the question? To understand it, let's take an example. Where is dog sitting? ChatGPT service will reach out to its GPT transformer model, where, and this transformer model is actually trained with web crawler data and lot of books. So what it will do, it will try to make sentence to answer this question. The dog is sitting at. Now what should come next? So what this transformer model has, it has list of words with probability. So what it will has, I'm just taking some example like mat, dog is sitting at mat, maybe probability 0.2, and dog is sitting on chair, probability 0.1, dog is sitting on floor, probability 0.4, dog is sitting on deck, probability let's say 0.3, and based on that training data it has the list of words along with the probability. So now the question is, which one can fit here? Is it dog is sitting at mat or chair or floor or deck? So now it used different algorithm. So it could be greedy. In case of greedy, like pick the highest probability. 1. In this case, what will happen? Dog is sitting at floor because floor has the higher probability. So that's the answer. But this will not work because this will be always a same answer. Dog is sitting at floor. It's kind of like if you want to order in a restaurant and there is a particular dish which is like most ordered dish, every time it will place an order for the same. That is not what ChatGPT is supposed to do. So ChatGPT need randomness. LLM model works based upon 3 parameters. Let's use top K, top P and temperature. So top K is simple, like if K is equal to 3 means pick the top 3 high probability words. Okay, and similarly top P means pick the words begin from top probability up to the point where cumulative sum of probabilities is less or equal to P. Then the word will be picked up here will be the top 3 one. The floor has the highest probability, second is deck, and third is mat. Let's say P is equal to 0.8. So how will it work? It will start from the top probability, highest probability, which is floor, probability 0.4, then deck, probability 0.3, 0.4 plus 0.3 is equal to 0.7, and mat will be 0.2 more, 0.7 plus 0.2 will become 0.9, which is more than 0.8. So mat will not be considered here. So now out of a big list of words, we picked up a small set of words. Now the major thing is like the temperature. So temperature, what temperature is? Temperature actually lies between 0 and 1. How it works? It works based upon the softmax function. What it does, so for your understanding, it's kind of like if the probability graph is like this, and if the temperature is like low, somewhere 0.2, 0.3, so what it will do, it will come out something like this. So the words which has like high priority, really high priority, will become like higher, and the word which are like low priority will become like clean and lower. So we can easily pick the high probability items here. But if the temperature is high, in that case what it will do, it will actually bring the low and high probabilities closer to each other, and what it will come out something like this. As a result of high temperature, what will happen, there are more chances to pick the words which has low probability, and it might result into off topic answer, because the word which has very low probability, system might pick them because temperature is high, which took the probabilities closer to each other. So here the chair probability, if I will just take an example, chair probability might be from zero point 0.1 to may come out to be something like 0.08, and the floor probability may be zero point 0.2, and similarly deck probability may be 0.1, and mat probability may be 0.09. So as you can see now, where floor probability was 0.4 and chair probability was 0.1, because of high temperature, chair probability and floor probability are much closer to each other, which is this third graph showing to you. And now there are pretty good chances to pick the floor probability. If you will put top P here now on these numbers, you will see that my P is 0.8, so it will begin from floor 0.2 plus deck 0.3 plus mat 0.39 plus chair 0.47. So we can pick all four words. And like if you are writing a code, so in the JSON, when you call the ChatGPT API, you can tune these three parameters K, P and temperature based upon the need. So what it will do, it will pick the word here and it will take them to next service, which will be fine tuning service. Fine tuning. Based upon lot of question answers, it fine tunes the answer. So now it will show it to user. So what it does, it use the reward model here. And reward model is same thing, like, you know, for a little kid, if he do good job and you just give him some reward or something, then it makes him or motivates him to do the same thing again. So if you clap, for example, okay, yeah, you did good job, great. So he'll put his best to do it again. So same way it works here. So what it is, when the answer goes to ChatGPT, the fine-tuned answer, user has an option to give like, okay, thumbs up, you like this or you like that. Sometimes you see like it shows multiple answers and user has an option to say, once user say like I like this one, then that reward goes to the reward service, and reward service again train the data here. We are using the system, we are at the same time training the system also, and so the user get the answer. So if I check here, functional requirement, ask question, user ask the question to gateway, ChatGPT service, it go to the transformer model where it use the top K, top P and temperature parameters and figure out the most suitable words. Then it goes through the fine tuning and then share the results. And the tuning has the reward model working in the backend where, like, you know, it gets the rewards, it get a chance from the user to get, you know, to get feedback and use that feedback as reward for the data, and the system further use that reward to answer other questions. So it is highly available, scalable service. It's all services are stateless, definitely. So they are, we use DynamoDB, and we talked about we can use simple S3 drive also. So that is also fine. Both are scalable, highly available. Seems like a great design, guys. Please subscribe my channel. Thank you so much.